Hello and welcome back. Now it is time to start thinking how to run our Docker app in production. At the time of making this course, Docker is getting more and more popularity, and many organizations are experimenting to run Dockerized applications in production. However, there are some different perspectives about Docker's use in production. On one hand, many Docker pioneers are confident that a distributed web app can be deployed at scale using Docker and have incorporated Docker into their production environment. On the other hand, there are still some people who are reluctant to use Docker in production as they think Docker workflow is too complicated or unstable for real-life use cases. So you might want to ask, is Docker production ready now? I would say it depends. Docker is on the bleeding edge of technology today. It is also one of the most compelling technologies of the last decade in terms of its disruption to software development, operations, system architecture, testing, and compliance practices. But Docker itself is still very young, and there are some concerns about running Docker in production. First of all, there are still missing pieces about Docker around data persistence, networking and security, and identity management. Also, the ecosystem of supporting Dockerized applications in production, such as tools for monitoring and logging, are still not fully ready yet. But because Docker's container technology is rapidly evolving, most of the concerns listed above are being addressed, and Docker is becoming considered as the standard for building distributed applications for production environments. Also, it is worth mentioning that many organizations are already using Docker in production, including Spotify, Yelp, and Betafy, etc. The most popular way of deploying containers at this moment is by first provisioning VMs and then deploy containers on the VMs. The main purpose of running containers inside VMs is for addressing security concerns. It is critical to ensure that one customer can access another customer's data or network traffic. At this moment, the isolation provided by Docker is still not as robust as the segregation established by hypervisors for virtual machines. Besides, without hardware-level isolation, all containers share kernel resources. If one container can monopolize kernel resources, it can starve out other containers on the same host in a denial of service, whereby legitimate users are unable to access part or all of the system. It is noted that most of the popular container management service, such as Google Container Engine and Amazon EC2 Container Service, still use VMs internally. The simplest way to provision new VMs and run containers on top of them is by using Docker Machine. Docker Machine can provision new VMs, install Docker tools on them, and link your Docker client with remote Docker machines. Here we have Docker Machine installed on my local box. Using Docker Machine, we can provision a VM on our local machine. To do that, we need a tool called VirtualBox, which is a virtualization technologies that allows us to install multiple guest operating systems on a single machine. If you're running Windows or Mac, you can use VirtualBox to provision Linux VMs on top of it. Docker Machine also provides different drivers for most of the popular cloud providers, such as Amazon AWS, Google App Engine, and DigitalOcean, etc., so that you can use Docker Machine to provision VMs in the cloud environment. In this course, we'll use Docker Machine to deploy our Docker app container in the cloud. Running containers in the cloud is quite different from running containers on your local box. Hello, and welcome back. We'll be registering a DigitalOcean account so that we can use it to deploy our app on DigitalOcean. DigitalOcean is a cloud infrastructure provider that can easily provision virtual service for you. It is similar to AWS EC2, but is much simpler to work with. Now we're at the DigitalOcean website. then type in your email address and password to register for an account. After clicking Create Account, DigitalOcean will send a confirmation email to you. Just log into your email account and click the confirmation link. After you have verified the email, you can refresh this welcome page or re-log into DigitalOcean account. Then you should see this Get Started button under the Update Billing section becomes clickable. Then click the button to update your billing information. DigitalOcean requires you to provide your credit card or PayPal account information before you can use their service. Because we're going to redeem a free DigitalOcean coupon, which should be enough for us to deploy the smallest VM, so that DigitalOcean won't take any money from your credit card account. But if you would like to provide DigitalOcean your PayPal account instead of credit card, DigitalOcean would pre-charge you $5, which will be used as DigitalOcean credit. After we have updated the billing information, let's find a free DigitalOcean coupon code. Here we Google DigitalOcean promotion. There are plenty of available coupons here. Just click the first entry. Then click Show Coupon Code. See, it prompts you the Droplet 10 coupon code. Copy it to the clipboard. And go back to the DigitalOcean account and click Billings. Scroll down the page and paste the coupon code in the promotion code text box and hit Enter to redeem the coupon. See? The coupon has been redeemed successfully. Now we have enough credit in our account to deploy a Droplet, which is basically a DigitalOcean VM. In order to access DigitalOcean account through its API to provision a VM, we need to generate a personal access token. Personal access tokens function like ordinary OAuth access tokens, which can be used to allow us to access the resources on our DigitalOcean account without typing password. Here we click API. Generate new tokens. Then give the token a new name. Just type Docker app. Click Generate Token. See, the token is generated. Click Copy to Clipboard and then save this token to a file or any other places, wherever is easy for you to retrieval, because we'll be using this token later to provision a VM on DigitalOcean. Hello and welcome back. We'll finally start deploying our Docker app to the cloud by using Docker Machine. If you install Docker Toolbox, you should already have Docker Machine installed. If not, just Google Docker Machine install. The first entry is the Docker Machine installation guide. If you're using Mac or Windows, you can install Docker Toolbox, which should include Docker Machine. If you're using Linux, follow this instruction to install Docker Machine directly on your Linux operating system. To verify if Docker Machine is installed correctly, just run Docker Machine ls, which will list all the VMs provisioned and managed by Docker Machine tool. See, currently we have one VM, which is running inside the VirtualBox on my local machine. Now let's take a look at how we can provision a VM in DigitalOcean. The command to use here is Docker Machine Create. It takes a double-dash driver option. Docker Machine comes with various drivers for most cloud providers, such as AWS and Windows Azure. Here we'll be using DigitalOcean. Just type DigitalOcean. Different drivers also have different options. For DigitalOcean, it takes a double-dash DigitalOcean -access and -token option, which is to specify DigitalOcean token. Just paste the token which we have generated in the last lecture. The last argument it takes is the name of the VM. Let's just name it Docker-app-machine and hit Enter to start provisioning the VM. This process might take a while. It involves requesting a new VM from DigitalOcean, installing Docker Engine on the VM, and generating the certificates. I'll fast forward the video until it's done. Here is how it looks like if everything goes smoothly. Now let's do Docker machine env to display the commands to set up the environment for the Docker client. As you see, the host we just provisioned has this IP address. Then we copy the suggested command to set up the environment variables, which should configure our Docker client to connect to the VM which is provisioned. Now let's do Docker info to display the system-wide information about the new VM. As you can see, the new VM has Ubuntu 15.10 installed and has about 500 RAM. Now we have our VM provisioned. Before we can actually deploy our Docker app container, there is one last change we need to make in the Docker Compose file. Because we should be using the Docker app image, which had passed all the tests on Circle CI and has been pushed to Docker Hub, instead of rebuilding the Docker image using Docker file locally. So here, we make a copy of our Docker Compose file and name it prod.yaml. Then we open the new YAML file and change the build section to image section and point it to the latest image on our Docker Hub account and save it. Finally, it's time to deploy our Docker app. Just do docker compose up-f. Put our new Docker Compose file. Then -d to start the containers in the background. This would deploy all the services defined in the Docker Compose file to the remote VM. It might take a while to download the Docker images. I'll fast forward the video until it's complete. Now the Docker Compose is done. Let's run Docker machine ls to display all the VMs. See? We get a new VM with name Docker App Machine, and it is running on DigitalOcean. And here is IP address. The second column is active, and it tells us which VM is currently the active VM. What active means is that when you run certain commands, if we don't specify which VM to apply to, it would automatically apply to active VM. Currently, our Docker App Machine is marked as active. Let's verify the container is actually up running in the cloud. Just copy the IP address of the VM and paste it in browser, column port 4000, and hit enter. See? We get our Docker app webpage displayed. If we log into our DigitalOcean account, you will see we have a Docker App Machine checked out. Actually, when provisioning a VM on DigitalOcean, there are quite a lot of options we can specify. Just Google Docker DigitalOcean driver. See? It got various options. You can specify which image to use, which geographical location to deploy your new VM, and the size of your image, etc. I hope you've enjoyed this lecture. I'll see you later. In the previous lecture, we have seen how to run Docker containers on a single host. What if you have a complicated system which consists of tons of containers and therefore can't fit into a single host? How can you scale Docker for large applications? Here is what Docker Swarm comes in handy. Docker Swarm is a tool that clusters many Docker engines and schedules containers. When you run a service through Docker Swarm, Swarm decides which host to run the container based on your scheduling methods. Let's take a look at how Docker Swarm works. I got some remote hosts in the cloud, and Docker daemons are running on those hosts. And we set up a Docker Swarm manager between the Docker client and those hosts. The Swarm manager will be connected each and every Docker daemon. So now, the Swarm manager knows the status of all the nodes in your cluster. When you decide to run a service, the Swarm manager decides where the service runs. You just need to point your Docker client to the Swarm manager instead of each and every Docker daemon. Basically, Docker Swarm can group multiple hosts into a cluster and distribute Docker containers among these hosts. So the workloads is divided by the nodes in the swarm, and this is transparent to the end users. In this way, it outsources the manual scheduling workload from the client to the swarm manager. It is also possible to point multiple Docker clients to the same Docker swarm manager so that multiple users can share the same swarm cluster. There are three important concepts about swarm: node, manager node, and worker node. A node is an instance of the Docker engine participating in the swarm. You can run one or more nodes on a single physical computer or a cloud server. But production swarm deployments typically include Docker nodes distributed across multiple physical and cloud machines. To deploy your application to a swarm, you submit your service to a manager node. The manager node dispatches units of work called tasks to worker nodes. Manager nodes also perform the orchestration and cluster management functions required to maintain the desired state of the swarm. Manager nodes elect a single leader to conduct orchestration tasks. Worker nodes receive and execute tasks dispatched from manager nodes. By default, manager nodes also run services as worker nodes, but you can configure them to run manager tasks exclusively and be manager-only nodes. An agent runs on each worker node and reports on the tasks assigned to it. The worker node notifies the manager node of the current state of its assigned tasks so that the manager can maintain the desired state of each worker. In the rest of this lecture, we'll be looking into how to set up a two-node swarm cluster on DigitalOcean. A swarm cluster can be composed of any number of swarm managers and any number of swarm worker nodes. In our setup, we will create two VMs, one for the swarm manager, the other for a swarm worker node. We can create the swarm manager VM using the same Docker machine create command we have used previously. We name this machine swarm manager. I'm fast forwarding this video until the provision is complete. We need to let our Docker client connect to the swarm manager VM. So just follow the instruction to run Docker machine env swarm manager. Then copy and run the displayed command to set up our shell. Next, we need to create another VM, which will be used as the swarm worker node. Again, we use the same Docker machine create command. Just name the VM swarm node. Now, we're done with creating two VMs. What we will do next is to appoint the first VM as the swarm manager. This can be done through docker swarm init command, which will initialize a swarm, and the Docker engine targeted by this command becomes a manager in the newly created single-node swarm. Before we can run this docker swarm init command, let's make sure the swarm manager VM is the current active VM by running docker machine ls command. As you see, there is a star sign in the active column for our swarm manager VM, which indicates this is the current active VM. Then we can issue the docker swarm init command against the swarm manager VM and hit enter. Oops, there is an error. Basically, what this error means is that since this VM has multiple network interfaces, Docker Swarm doesn't know which one to use to communicate. Usually, when you provision a VM on DigitalOcean, by default, the VM comes with two IPs. One is a public IP address, and the other one is a private IP address. The public IP can be accessed from anywhere else, but the private IP can only be accessed by hosts in the same data center. This is a feature of DigitalOcean which allows private networking between hosts in the same data center. Here, we just pick up the public address to bootstrap our swarm cluster. So we run docker swarm in a --advertise-addr and paste the public IP, then hit enter. Now the swarm cluster is successfully initialized. And swarm also gives us a command to run if we want to add a swarm node into the swarm cluster. Just be aware that this command needs to run on the worker node. So here, instead of switching the active VM, we can run docker machine /sh command to /sh into the swarm worker node VM. Now we're inside the swarm worker node VM. Just copy and paste the command here. See? This work node has joined the newly created swarm cluster. In this way, we have created a 2-node swarm cluster. Let's recap. We have introduced 2 important Docker Swarm commands in this lecture. Docker Swarm init command will initialize a swarm. The Docker engine targeted by this command becomes a manager in the newly created single-node swarm. Docker Swarm join command will join a swarm as a swarm node. In case you want to disconnect a node from a swarm cluster, you can run docker swarm leave to leave the swarm. In the previous lectures, we have created our swarm cluster. In this lecture, we're going to actually deploy our services to the cluster. The services can be defined in our Docker Compose file. We have previously defined our Docker app and Ready services in Docker Compose file. The service definition includes which Docker images to run, the port mapping, the dependency between services. When we are deploying services in the swarm mode, we can also set another important configuration, which is the deploy key, and it is only available on Compose file formats version 3.x and up. The deploy key and its sub-options can be used to load balance and optimize performance for each service. Let's take a look at this Docker Compose file. In the deploy key, we set the replicas to 3, which means Docker will run 3 instances of the Nginx image as a service called Nginx. So what is a replica? Let's take a look at the below diagram. When you deploy the Nginx service to a swarm, the swarm manager accepts your service definition as the desired state for the service. Then it schedules the Nginx service on 3 nodes in the swarm. Each node will be running an Nginx container and is called a replica. So why we want to run the same containers across multiple hosts? This is for scalability and high availability, meaning that your application can scale when the number of users increases, and your application can still remain online even if one of your containers goes down. You might want to ask, can I access the Nginx container from any of 3 hosts? Yes, you can. As you see, we're asking Docker to publish port 80 as an available port for the Nginx service. When Docker publishes a port for a service, it does so by listening on that port across all nodes within the swarm cluster. When traffic arrives on that port, that traffic is then routed to a container running for that service. So you can access Nginx by visiting port 80 on any of the 3 hosts. While this concept is pretty standard when all nodes are running a services container, this concept gets interesting when we have more nodes than we do replicas. Let's say you have 4 nodes in your swarm cluster and swarm deployed 3 replicas of Nginx service. What if you hit 80 port of the node which doesn't have the Nginx replicas? What would happen? The answer is that you will still be able to connect to the Nginx service through a node which does not have Nginx replicas. Docker calls this ingress load balancing. The way it works is that all node workers listen for connections to published service ports. When that service is called by external systems, the receiving node will accept the traffic and internally load balancing it using an internal DNS service that Docker maintains. So even if we scaled out our Swarm cluster to 100 node workers, end users of our Nginx service can simply connect to any node worker. They will then be redirected to one of 3 Docker hosts running the service containers. All of this rerouting and load balancing is completely transparent to the end user. Besides replicas, you can configure things like limiting each replica to use at most 10% of the CPU across all cores and 50 MB of RAM. You can ask Docker to immediately restart containers if one fails to ensure that your service can always be online. Through all this, Docker aims to provide building scalability and high availability support for the service deployed on Docker Swarm cluster. Before we can deploy our Docker app service to Docker Swarm, there is another important concept we must understand: Docker Stack. This is a new concept in the Docker Swarm world. A Docker stack is a group of interrelated services that share dependencies and can be orchestrated and scaled together. You can imagine that a stack is a live collection of all the services defined in your Docker Compose file. When you have a Compose file, you can use Docker Stack Deploy command to create a stack from your Docker Compose file. In the Swarm mode, we can reuse the Docker Compose files for service definitions, but we can't reuse the Docker Compose commands anymore, such as Docker Compose up, Docker Compose down. Docker Compose commands can only schedule the containers to a single node. In the Swarm node, we have to use Docker Stack. You can think of Docker Stack as the Docker Compose in the Swarm mode. Let's see how we can deploy a stack which are composed of our Docker app and Redis services to the Swarm cluster. First, we open our production Docker Compose YAML file and add a deploy key to our Docker app service. Then we set the replicas to 2 so that we would deploy 2 Docker app containers in the Swarm. And save the Docker Compose file. Next, let's create a stack from our Docker Compose file and deploy it to Docker Swarm. This can be done through a single command, Docker Stack Deploy. In the --compose -file option, we supply the file path to our Docker Compose file. Then, we give the new stack a name. Let's call it Docker app_stack. And hit enter. Now Docker Swarm has created an overlay network for us called Docker app_stack_default for a cross-nodes communication. This default network is created automatically when we call Docker Stack Deploy. Usually, we do not need to customize configuration. Then Docker creates both the Docker app service and Redis service for us. We can list all the stacks on the Swarm cluster by running Docker Stack ls. Right now, we only have a single stack composed of 2 services. We list out all the services in the stack by running Docker Stack Services and provide the stack name. As you see, we have 2 services running. The Redis service has 1 replica, and the Docker app service has 2 replicas. Let's try to access our Docker app service. List the IPs of all running VMs. As we have learned before, we should be able to access the Docker app from any of the hosts because of the ingress load balancing feature of Swarm. So let's copy the IP of the Swarm node VM in the browser. we paste the IP and access port 5000. See? We're connected to our Docker app. We can also try the other host. As you see, we can access Docker app from this host as well. You might want to ask, in production, what if we want to update some of the services? What should we do? We can simply run our docker stack deploy command, and Docker will update our services automatically on the Swarm cluster. Let's see it in action. Let's say we want to explore port 4000 instead of port 5000. We update our Docker Compose file first and change the host port mapping to 4000. Then we will run our docker stack deploy command. See? This time it says updating services instead of creating services. Now we can list all the services. As you see, the port mapping has been updated to 4000. We can verify that by ourselves. Just go to the browser. If you try with port 5000, we get a connection refused error. If we change to port 4000, now we're connected to our Docker app. With Docker Deploy, we can also easily scaling our services. Let's say we want to add one more container for the Redis service. Just add a deploy key to the Redis service and set the replicas to 2. And rerun docker stack deploy command. And list all the services. See? The Redis service has 2 replicas as well. This is the last lecture about deploying our Docker app on Swarm cluster. As a friendly reminder, if you don't want to use any VMs on DigitalOcean in the future, you should destroy them. Otherwise, they will cost you money. Don't just shut down them, because powered up VMs will cost money as well. Make sure they're destroyed.